lecture, we have going to discuss about the machine cycles of 8085. Before going into that, we have to get a recap of the previous lectures. Like we have discussed architecture of 8085. 8085 is nothing but as 8-bit microprocessor, and this processor we have discussed architecture, pin diagram, interrupts, and addressing modes and instruction formats, etc. So we have two main signals like control signals and status signals, right? So what these control and timing signals depend upon the mission cycles. So before getting into that, we need to know what are the um, addressing modes and instructions format we have. We have three types of instruction format like 0 byte, 1 byte, 2 byte, and depending upon that, we are writing the addressing modes like direct addressing mode, indirect addressing mode, and immediate addressing mode. Etc. So in this, depending upon these addressing modes, we are going to see what are the mission cycles available for each request. Right? So what is this mission cycle is nothing but the time required to access the memory or input output device is called as mission cycle. What is the T state? So now we know that a mission cycle is nothing but the time taken by the device to recognize the memory or input output. So what is this T state? The mission cycle and instruction cycle takes a multiple clock periods. So it takes a multiple clock periods, right? So the portion of an operation carried out in one system clock is called as T state. The portion of operation carried out in one system clock period is called as T state. And what are the mission cycles we have is 8085 microprocessor has 5, that is up to 7 basic mission cycles. The main 5 is opcode fetch cycle, that is 40. Opcode fetch cycle, memory read cycle, and memory write cycle. First one is opcode, that is instruction fetching, memory reading, memory writing. And next one is input output read cycle and input output write cycle. So we know that once we get an instruction, we go for opcode, and next for memory read, memory write, input output, and write cycle, right? So these times, that is T is nothing but the T states for each fetch cycle. And here you can see you have T1, T2, T3, T4. That is the total T states. We have 4T, where the opcode fetch comprises of 4T. And first one is clock signal. We have a clock signal here. And we have the higher order memory address, that is from A8 to A50. And A0 to A7 we have lower order. So higher order is A8 to A15 and lower order is A0 to A7. And AL is nothing but address slash enable. So we are enabling here, and we have the input output memory, whereas the status first will be given and input output depends upon the selection lines. And we have the read signal. So read also depends upon the opcode which is given in the lower order. Okay. So we can see the opcode fetch mission cycle of 8085. Each instruction of the processor has 1 byte opcode, right? The opcodes are stored in the memory. So the processor executes the opcode fetch mission cycle to fetch the opcode from the memory. So what is the main purpose? To fetch the opcode from the memory. Is every instruction starts with opcode fetch mission cycle. The time taken by the processor to execute the opcode fetch cycle is 40. So you can see here is T1, T2, T3, T4. In this time, the first 3 T states are used for fetching the opcode from the memory, and the remaining T states are used for the internal operation. So here you can see this is to fetch, and another is for operation of the processor, internal operations of the processor. And memory read cycle, what is this is the memory read mission cycle is executed by the processor to read the data byte from the memory, So the process takes 3T, where the opcode takes 4T, the memory read takes 3T, and memory write signal is executed by the processor to write the data byte in the memory location. This is also 3D. Input output read cycle, where it takes executed by the processor to read the data byte from the input output or from the peripheral. The processor takes 3T stages to execute this machine cycle. IN, the instruction uses its machine cycle during the execution. So we have basically 5 types: opcode, memory read, input read, and input write.